Alright, so concentration is going to be defined as the amount of solute that is dissolved in a solvent. So you give it as the amount of solute per solvent, okay, dissolved in a solvent. Now I don't want to say a lot of things on the solvent. I can either say liters of solvent, kilograms of solvent, or whatsoever. So basically concentration is just, and you can see on top we have just said amount. It can either be mass, moles, or whatsoever. So this is the general definition of concentration. But there are different types of concentrations. The first type of concentration we are going to talk about is molarity. Take note of the spellings molarity, and the symbol is capital M. So molarity is a type of concentration which is defined as, instead of just saying amount, we say number of moles of solute, okay, divided by the volume of solution. So this is molarity, number of moles of solute over volume of solution. So we also say capital M, please, this is capital M, is equal to N divided by V. And so the unit for molarity is given as mole. We know that number of moles given in moles, right? So it's going to be mole per liter. Now, mole per liter is the same as molar. This capital M we are seeing is also called molar. So a molar is the same as mole per liter. Now we know that a liter is equal to a decimeter cubed. So molar is the same as mole per decimeter cubed. So this is the same, since 1 liter is equal to 1 decimeter cubed. So 1 molar is equal to 1 mole per decimeter cubed. So this is molarity with R here. So we can do just a very simple example on how to calculate molarity. So let's get to say we've been given, let's say 25.3 grams of potassium nitrate. When you get to calculate the molar mass of potassium nitrate, is 101.1 grams per mole. Okay, so 25.3 grams of potassium nitrate, let's say, is dissolved in, I can say, 50 mils of water. Calculate the molarity. Yes, I don't know what's the question.
Yes, I would like to find out something. I'm considering the two. Is there any similarity between molar mass and relative atomic mass?
Okay, so you can use them interchangeably. Relative atomic mass is a mass of an element compared to 1/2 of the mass of carbon. That is basically the mass that you see on the periodic table. Now molar mass is the mass of 1 mole. So if there was a 2 in front here, you don't say it's molar mass, because this is 2 moles. But a mass of only 1 mole of a substance, that is called molar mass. So the molar mass is the same as the relative atomic mass of an element. Okay? Alright. Now we've been given this question here. 25.3 grams of potassium nitrate with a molar mass of 101.1 grams per mole is dissolved in 50 milliliters of water. Calculate the molarity. Now we know that molarity, what's the formula for molarity?
Molarity is equal to M over the
O-
number of moles over volume.
Okay, number of moles over volume. But we haven't been given the number of moles here. We also know that number of moles is mass over molar mass. So the mass, therefore, which is 25.3 grams, the molar mass is 101.1 grams per mole. So the grams and the grams will cancel, so see that the answer is going to be in just the moles. So therefore, if you get to divide, what has anyone found the answer? 25.3 divided by 101.1.
It's 0.024727992.
Okay.
0.024.
Now me I found 0.25024 as a number of moles. And then we'll come in the formula. So molarity therefore is going to be 0.25024 moles over the volume. Now remember the volume should be in liters. Now we've been given milliliters. So to convert from milliliter to liter, simply divide by 1000 or multiply by 10 to the power negative 3. So I'm going to say 50 times 10 to the power negative 3 is now in liters. We've converted. If you want, you can use the conversion that we've always been talking about. So the value that we are going to get for this one is 5. So it's 5 mole per liter. Now mole per liter is the same as molar. So I can also say that the answer is 5 molar. Capital M. It's molar like this with R at the end. We are good? Yes?
On the conversion part, from behind the picture.
You can use any conversion that you know. But just know every time you are moving from milliliter to liter, just divide by 1000 or multiply by 10 to the power negative 3. But you can use any other conversion that you know. So that is basically molarity. Now the next type of concentration we are going to talk about is molality. So these are two different types, and here the symbol is small m. So molality, you can see there is L there instead of R. Okay, and the symbol is different. Now, the difference between molarity and molality is just the formula. Okay. Does anyone know? Has anyone come across this? Who can tell us? Anyone? Okay, molarity is given as mole of solute per kg of solvent. So instead of saying mole over volume, it's mole over mass. So that's the difference. And so this one is given as small m, which is molarity, is given by number of moles over mass. Now I can't also still use m for mass, so I'll just finish it as mass. So therefore the unit for molarity is the number of moles per mole per kg. Now mole per kg is also called molar. Now this molar is different it ends with L at the end. It's different from the other molar which ended with R at the end. So you see these as you go on in chemistry, especially this one, the molality. We are going to be using it when you start talking about colligative properties. It's very, very important. So we can consider a question. So let's say we have got 20 grams of sodium hydroxide, which is dissolved in, let's say, 50 milliliters of water. Yes, there's a question.
The units of molality, I haven't seen it. It hasn't shown on the screen.
Oh, it's more per kg. Okay. Are you able to see the question?
Yes, sir.
All right. So 20 grams of sodium hydroxide is dissolved in 50 milliliters of water. We want to calculate the molarity. We know that molarity is small m is given by number of moles over mass. So the first thing we need to find the number of moles. And this is number of moles of solute what you are dissolving. So they can actually even give you the molarity. They give you the number of moles. They ask you to determine the molar mass. This shouldn't be something that you get to wonder. How do you find the molar mass? So you get to just find, if they've given you the mass, the molarity, they ask you to find the molar mass. First find the number of moles. Okay, after find the number of moles, you can now find the mass. You know that mass is number of moles times molar mass. So let's find the number of moles. That is given by mass over molar mass. Now we need to know the molar mass for sodium hydroxide. We know that the mass for sodium is 23, oxygen is 16, hydrogen is 1. Sorry, just a moment. It's taking a bit of time to show here. Okay, please confirm with me if you can now see.
Yes, sir.
Alright, so what I'm determining here is the molar mass for sodium hydroxide, which is 23 plus 16 plus 1. That is going to give us a 40. So the number of moles of sodium hydroxide is going to be mass, which is 20, over molar mass, which is 40 grams per mole. This is going to give us 0.5 moles. The next thing we need to find is the mass of the solute. What you've been given is the mass of solvent. Now we've been given the volume of the solvent, 50 mils. Firstly, I need to convert this 50 mils. Let me put it, instead of 50 mils, let me say it's 500, so that it will just be convenient. Okay, we have the volume as 500 mils. We first need to convert from mils to liters. So volume is going to be 500 milliliters. To convert to liters, just multiply by 10 to the power negative 3. So this is the same as what? 0.5 liters. Alright, so divide by 1000 or multiply by 10 to the power negative 3. Now we have got the volume. We know that the density of water is 1 kg per liter. So it means if we have got 0.5 liters, it means we have got the mass as 0.5 kg. Okay, that's the mass of water that we are dissolving in. So therefore the molarity is going to be number of moles, which is 0.5 moles, divided by the mass, which is 0.5 kg. This is going to give us 1 mole per kg, which is also 1 molar. Now 1 molar, this is a standard concentration, right? It's a standard concentration of 1 molar. Are we okay? Yes.
So sir, as in we can't convert the 20 grams into kg. Just leave it like that.
No, like when you are finding the number of moles, you use mass in grams. It's mass over molar mass. So there are two different things here. There is a solute and there is a solvent. So for the solute, that thing you are dissolving, the mass should be in grams. Okay? But for the solvent where you are dissolving into, the mass should be in kgs. Is that okay? Is that okay?
Now how do you come up with that same mass in kg?
So you've been given the volume of the solute, I mean the solvent. Simply convert the volume to mass. Now firstly make sure that this is not in milliliters but in liters. If you find it in liters, 1 liter of water is equal to 1 kg of water, because the density of water is 1 kg per liter. Meaning that whatsoever volume you are going to find in liters is going to be equal to the mass in kgs. Okay? Is that okay? Alright, so the next type of concentration that you need to know, we've talked about molarity and molality. Another one you need to know is formality and normality. Now, I'm not going to talk about those two because they are less of concentration, right? You also have formality and normality. Now, formality is given as a gram formula unit divided by the number of by the volume. The gram formula unit is the same as moles. Now the only difference is that for formality is more specific to ionic compounds, right? For ionic compounds like sodium chloride is an ionic compound. So remember when you're talking about relative masses, we talked of relative molecular mass and the relative uh, formula mass. Okay, I've got the formula mass and the molecular mass. Molecular mass is for molecules like water, ammonia, but formula mass is for ionic compounds. So it's basically the same thing. Sorry again that it is taking a bit of time to show. Hope now you can see. So as I was saying, if you say the molar mass, the relative atomic mass for chlorine is 35, relative atomic mass for sodium is 23, you add them. What you have found is the relative formula mass because this is an ionic compound. But if it was water, you get the total masses. What you'd find is the molecular mass or relative molecular mass. So because of that, it will give you a difference when you are finding the number of moles. If you say number of moles of an ionic compound, we call it gram formula unit. So gram formula unit is given as just like number of moles is mass over molar mass. A gram formula unit is mass over formula mass. That's the only difference. Sorry, it is taking a bit of time for it just to show what I'm writing. That's why I'm minimizing to write. Yes, Priska. Priska, your hand is up. So I hope we have gotten what I've said. So formality is just number of moles over volume. Now, since this is an ionic compound, we are not calling it number of moles. We are calling it gram formula unit. Gram formula unit, which is basically mass over formula mass because ionic compound. Okay, so it's just the same as the molarity. Formality is the same as molarity, except it is specific for ionic compounds. So 1 4 mole is the same as 1 mole per liter. Okay, but this mole we are calling it gram formula unit, but it's the same as mole if you are to write it in a formula. Is this okay, friends?
Yes, sir. Sir, it is confusing what you're explaining now.
Okay, let me use an example. Let me say sodium chloride. Let's say you have got 20 grams of sodium chloride. Okay, you know that this is an ionic compound. Let's say the molar mass. Sodium we know that is 23, chlorine is 35.5. Let me say just 36. 23 plus 36. So let's say the molar mass is 59 grams per mole. Okay, for sodium chloride. Now, when you have been given an ionic compound, you find this value here, I'm calling molar mass. You call it relative formula mass because it is an ionic compound. If it was a molecule, it is called relative molecular mass. If it is an atom, you call it relative atomic mass. That's the difference. Relative atomic mass is the mass of an atom. Relative molecular mass is the total relative atomic masses of a molecule. Relative formula mass is the total atomic masses of an ionic compound. So this value I have found is relative formula mass. This is an ionic compound. So what I'm going to find, instead of me finding number of moles as mass over molar mass, what I'm going to find is formula mass. Okay, gram formula mass, which is given as mass over relative formula mass. But it's the same as number of moles because it's the same formula, except it is C, an ionic compound. So it's going to be 20 divided by 59. Okay, this answer that you are going to find is the gram formula mass. But since you find it using the same formula as the number of moles, so the answer is going to be in moles. So it means that for you to find formality, is simply going to be this same value which you found as the gram formula mass, which is in moles, over volume. I don't know the volume of the solution. So that is how you find. Let's say you dissolved in 20 grams of water. I mean 20 liters of water. So it will be 20 liters down. And then on top you have got 20 over 59. So this is what I'm saying. Is that okay? Back then, are we together?
Yes, sir.
All right. Another type of expression of concentration, I hope you can see. Okay, another expression of concentration, we are now normality. Now, I'm not going to talk about normality. Normality is equivalent weight over volume. Now, I will not talk about that. Maybe at another level. Unless you tell me it is of importance in one paper, otherwise it's of little importance for first year chemistry. Unless for something. Now I'm going to go to percentages. Right? We have got percentage, weight by weight. This is another type of expression of concentration. So percentage weight by weight is given as the weight of solute over the weight of solution. multiplied by 100%. Now this weight is in grams, all right? It's either in grams or in kgs. That is percentage weight by weight. So simply weight over weight times 100. They should be in the same unit because at the end you want those units to cancel out and then you multiply by 100%. That's why we're calling it a percentage. You also have percentage weight by volume. Now percentage weight by volume is a weight of solute, right, divided by the volume of solution. And then the answer you're going to multiply by 100%. So from here you can determine that there should also be percentage volume by volume. I want someone to guess what is going to be the unit. I mean, what will be the formula? What will be the formula?
Volume of solute over volume of solution.
Very good, just that. Volume of solute over volume of solution. Please make sure that these are in grams, all right? Make sure that the weights are in grams. Like here, you can see we are talking about two different units. So on top you have got weight, down you have got volume, which is in liters. So don't use in kgs here, all right? Make sure that you use in grams. The weight of the solid should be in grams. For example, if they've given you sodium chloride, which is being dissolved, let's say 20 grams of sodium chloride dissolved in 50 grams of water. So therefore the percentage weight by volume is going to be what? You get a weight of the solute, which is 20 grams, over the volume of solution. So this should be solution, not just a solute. So in this case, I'm going to say that the solution is 50 grams. Now you need to make sure that it is in what? Liters. So convert to liters. Now first thing, since this is 50 grams of solution, convert the 50 grams to kg. How do you do that? Just divide by 1000, isn't it? So that will give you 1, 2, 3. That is going to be 0.05 kg. So 50 grams is the same as 0.05 kg. Now since the density of water is 1 kg per liter, if you have got 0.05 kg, this means that you have also 0.05 liters. So this is the volume of solution. So 0.05 liters. Make sure that it is in liters and then multiplied by 100%. So the answer that you are going to get, let's see what I get here. That is 20 divided by 0.05 multiplied by 100. Though it has given me a very big number, I've just made up the question anyway. It is 40,000. So the answer will be 40,000 percentage weight by volume. That's also the unit. 40,000 percentage weight by volume. So these are other expressions of concentration. And you are going to find questions on this. Apart from percentages, concentration can also be expressed as density. Density is also a type of concentration. And you know that the density, the symbol is rho, is given by mass over volume. It's just that you can see instead of you using the mass of solute in number of moles, instead of using the amount in moles, you've used the mass. And then the solution, you've used volume. But if this was opposite, or let's say on top you had number of moles and then down you had mass, this thing is molarity. So you need to know, just by looking at the formula, you should identify what type of concentration that is. So density is also another type of concentration, and we've been working with density from grade 8, 9. Yes,
As in everything you said, I don't know, was I right or maybe nothing was there?
I think nothing was there. So you don't need to know that. I think density is mass over volume. That's what I've said. Okay? Is it okay? I think you already know this. All right. Now, other types of concentration, you express them in parts. So we first have parts per, we'll start with thousand, parts per thousand, ppt. This is a type of concentration, and you give it as it can be anything, all right? Amount of solute over amount of solution times, since this is parts per thousand, it will be times 1000. Now 1000, I'll base write it as 10 to the power 3. That's parts per thousand. Now if the amount on top is in kg, make sure that the amount down is also in kg. If the amount on top is in liters, make sure that the amount also down is in liters. If the amount on top is in moles, make sure that the amount down is also in moles. Okay, that is parts per thousand. You also have parts per million. Parts per million is the same amount on top over amount down times, now you multiply by a million, 10 to the power 6. You also have parts per trillion. Now I can't differentiate parts per million, per thousand, and parts per trillion, but you also have that. So that is going to be amount of solute over amount of solution times trillion, which is 10 to the power 12. You also have parts per billion, which is amount of solute over amount of solution times a billion. A billion is 10 to the power 9. So just make sure that if on top you have got mass, down you should have also mass, and they should be in the same unit. These are expressions of concentration which you are going to come across. Let's just give one example on this. Let's say 20 grams of sodium chloride is dissolved in, let me say, uh, 2 liters of solution. Calculate the concentration in parts per million, parts per billion, and parts per trillion. Okay, let's calculate these type concentrations. Now the first thing I need to convert this, since I've got the mass of sodium chloride in grams, I need to convert also the solution to be in grams, right? So we know that since this is a solution and we are assuming it's a solution of water, so if we have got 2 liters, it means we have got 2 kg, right? Now I don't want to be in kg, I need to be in grams. 2 kg is the same as 2000 grams. Okay, we have found that. So meaning that the different types of concentration, this is 20,000, I mean 2000 grams. So meaning parts per million is going to be the concentration of the solute, which is 20 grams, over concentration of the solution, which is 20,000 grams, times a million, which is 10 to the power 6. So 3 zeros here are going to cancel with these 3 zeros. So we're going to remain with 3 zeros there. These two go into that 2, alright? So we're going to have 10 multiplied by 1000. So therefore the answer there is 10 multiplied by 1000. That is just 10 to the power 4 parts per million. That's a concentration. If we go in parts per billion, it will also be 20 over 2000. but multiply by a billion, that is 10 to the power 9. Three zeros will cancel with the three zeros which you are able to see here. So I'm going to remain with 6 zeros, right? And then these two can go into that two. We're going to have 10. So 10 times 10 to the power 6, that is basically 10 to the power 7 parts per billion. To find parts per trillion, just use power 12. So from here, you should be able to determine which one is bigger. Is it parts per million or parts per billion? So which one is bigger? If we say 1 part per million and 1 parts per billion, which one is bigger? What would you say if it were you? Which concentration is bigger? Like which one is a more concentrated solution? 1 part per billion or 1 part per million? So 1 part per million is a more concentrated solution than 1 part per billion. The reason is simple. A billion, it means the denominator is much bigger. Alright? In other words, you have got 1 part in a billion of the solution. Now here you have got 1 part in a million of a solution. So a million is smaller than a billion. So in other words, when you get a drop of water in a river and a drop of water in an ocean, so this drop will be more meaningless in an ocean than it will be in a river. That means that in a river, this drop is going to make more sense. It's going to be more concentrated. Okay, I can also say, let's say you get a spoon of sugar, you put in a cup, and the same spoon of sugar you put in a jug. So in a cup, it will be more saturated, meaning is more concentrated than it is in a what? In a jug. That is the same with parts per million and parts per billion. Parts per million is smaller than parts per billion. So that is why parts per million is more concentrated than parts per billion.